It's a pleasure to be here. And of course, as you said, I'm going to be saying a little bit about BGS. So my talk's probably going to be the least interesting of this entire conference. I looked at yesterday's program. Fortunately, I couldn't attend. But I've also looked at today's program, and there's some really interesting things on here. And you'll actually hear from between yesterday and today from several BGS people as well, a little bit more about the actual maps that we do. So I will do the sort of more boring stuff, if you will, of just introducing BGS. But again, let me reiterate that I'm very happy to be here. I too wish that this could have been an in-person meeting. But I think it is important that we still continue to have these kinds of events online when we cannot meet in person. So let me just share my screen. Coming there. And I hope everyone can see that. Otherwise, give me a shout. So BGS, it's in very, very short, it's all about understanding the Earth. And I could stop right here, but obviously that would be a little bit leaving too much to perhaps imagination. So let me just dig a little bit deeper. What do I mean by saying we need to understand the Earth? Lots of different organizations do geoscientific research, but a geological survey has sort of a special remit. There's just one per country pretty much. And most geological surveys have more or less the same sort of role in society. And ours can be sort of summarized in our vision and mission, which is for a safer, more sustainable and prosperous planet and a future based on sound geoscientific solutions. And we have a mission statement that's actually much, much longer than what's on this slide, but this is sort of the essence, if you will, of our mission is to provide impartial and independent geoscience advice and data. And to do that and to be able to deliver that, we observe, monitor, and characterize geological environments. And we do science that's focused on sensing, understanding, and predicting the Earth's behavior and delivering solutions for the national and global good. And that is really key words there, the national and global good. It's all about how we can take our knowledge and our data and help society with some of the challenges that we see. A little bit more pinned out the role. We act as we provide the national repository for data and knowledge for geoscience in the UK. This is both maps, which of course we love, that's why we're here, but it's also rocks, which we also love, and all kinds of other data, geophysical data, geochemical data, any type of geoscientific data, really. We develop services based on this, and we provide impartial and independent geoscientific advice to government, to industry, and to the general public. We provide analytical facilities, including observatory networks in support of earth science research and government needs. And we deliver UK leadership in our field, and we make our skills and expertise and knowledge available globally. And we undertake research and development in pursuit of these aims, which really is just sort of means that we do research together with other geoscientists across the UK and across the world, really, to make sure that we have the appropriate skills and the appropriate knowledge to actually be able to deliver the data and knowledge and advice that we need to deliver at BGS. So I'm actually not going to say a lot about the science structure. I think it said in the program I was going to talk about our challenge areas, but I'm not actually going to talk that much about them. But let me just briefly introduce them. We have basically a science strategy that's called Gateway to Earth. And in that, we are summarizing how we go about delivering that role that we have to deliver. And we've basically very much inspired by the UN Sustainable Development Goals and societal challenges, as also sort of hinted at in our vision. We have organized our work and actually also our staff, as it turns out, into 3 challenge areas and a bunch of stuff that supports and underpins that. So we have here decarbonization and resource management. That's all about how we help the energy transition, how geoscientific knowledge and data can support the energy transition. We have a challenge area that's called environmental change, adaptation, and resilience. This is all about the environment that we live in, which is under influence by climate change, by energy transition, and it is typically things to do with groundwater and other sort of important things in the subsurface. And then finally, at the bottom here, you have multi-hazards and resilience, our third challenge areas, which is everything volcanoes, earthquakes, coasts, and the like. There's, of course, enormous overlap between these three, because a lot of the decarbonization challenges will have environmental impact, maybe hazards impact, but we work across the entire organization, really focusing on delivering solutions to those three societal challenges. Underpinning that, we have our operations, our innovation, our business development, our public engagement, and also our digital transformation. And I know you'll hear more about that from Kate Royce later today. So digital transformation, as in both how do we actually deliver data, but also how do we ourselves work digitally to deliver our work. And then we have also an area of national and global geoscience. And it's sort of put on here as almost sort of an overarching theme. And basically what that is ensuring, in a sense, that we not only find solutions for these societal challenges, but that we also think about how we implement these solutions, and we help people and places integrate the solution. So this is very much about the maps. This is very much about how do we on a national scale find geoscience solutions to different things, and also how do we do it on a global scale. So this is where a lot of our mapping exercise is sitting. A little bit of history. We founded in 1835 with the oldest geological survey in the world. It started out with systematic geological mapping or surveying of the entire UK, which was very much motivated by strategic resource needs, which is just another word for saying societal challenges again. What is it society needs? And that is really why surveys are sort of put into existence in the first place. Initially, and still, we work very closely with the then also newly established Ordnance Survey. And we've maintained a really close relationship with the Ordnance Survey for example, printing services all the way up until the digital age. But we, of course, share some of the geospatial information with the Ordnance Survey. And we are today partners in the Geospatial Commission with OS as well. We were early pioneers of the digital geological mapping, and we currently have one of the world's most comprehensive digital maps. And the idea was really to complete a geological survey, or geological mapping, if you will, of the UK at 1 to 50,000 scale, based on 1 to 10,000 and 1 to 25,000 scale in GIS formats. The last area to actually be surveyed, and so we started almost 200 years ago, and we're not actually quite there yet, but we're almost there. It's currently underway, and it's the Knighton district. We continuously upgrade and update the maps that we have, and we integrate with subsurface knowledge. I think should have been written in there as well, not the word knowledge, but it is sort of prioritized together with stakeholder needs, really. So, for example, we are just starting up a mapping project together with the Environmental Agency in York, looking at both the map but also the subsurface, and this is very much to do with groundwater and groundwater resources. We have developed the UK 3D, which is the first national geological model, which is originally developed as a communication tool to really sort of illustrate the nature of geology below the surface, in the subsurface. And subsequently, this model has been developed both in sort of extent and volume for the RAD waste program that's led by the Radioactive Waste Management group. And so it is one of these things that is now a resource that can be built on for specific needs. Again, prioritized by stakeholder needs, we can go in and continue to add data onto our 3D mapping. And we're actually moving into 4D mapping in the sense that we also are looking at development with time, maybe not so much geological timescales, but our own timescales. And one of the ways we're doing that is with, for example, the UK Geo Energy Observatories, or UKGEOS as it's called, facilities. And just very quickly on that, the UK Geoenergy Observatories are a £31 million investment from government on behalf of NERC UKRI, and it is really a facility that will be available to the entire academic community. And what it is, it's two geoenergy observatories, so observatories that aren't looking up towards the sky, but looking down into the ground, in Glasgow and in Cheshire, and also supported by a core scanning facility, because we are retrieving cores to be able to put that observatory into the ground. And basically the idea is Glasgow is already operational. Cheshire will be probably drilled and established later this year and next year. But basically the idea is that these drill holes are equipped with all sorts of sensors and equipment, and that we will stream data in pretty much real time from the UK geosites for any scientists that are interested in geological processes to use. And also people can design experiments using the facilities themselves. So that is the new 4D mapping. And I want to just show this. It's really, really messy, and you're not really supposed to look at it in very great detail, but this is our data ecosystem, if you will. So all of the many, many different databases and data products that we are delivering to various parts of society. And there's some lines on here that basically show you which data goes into these different products. And what I really just want you to see is these two things here that are in a fat box, the 10K geological map and the 50K geological map. Almost everything that we deliver is basically based on our geological mapping. And we all know, I think, that if you want to do something in an area, whether you want to do infrastructure or you want to do, you want to drill for resources, you want to think about your groundwater systems, any of those things, the first thing that any contractor is going to ask for is a geological map. That's basically where everything starts. I like to say it starts with the rock, and it really does start with the rock. So the geological maps that have been produced over the last almost 200 years are critically important for us in delivering the different types of tools that society actually needs. And I'm almost done. I just wanted to show this here. These are publication records for 2020. And we have a total publications from BGS at 555. All kinds of different publications. Some are peer-reviewed, some are more reports. But as you can see here, when you look at the NORA, which is the NERC Research Center's database for publications, in 2020, there were 322,562 downloads of things produced by BGS. And a lot of this, again, is based on our maps, as we saw in the previous slide. And we actually are responsible for 11 of the 20 most downloaded articles for all of the 6 research centers. So we're very pleased with that. And just in case you don't know where we are across the UK in many different places. We have sort of main offices, as you can see in the sort of buff color here, but then in the blue, smaller diamonds, we have our observatories and various facilities across the UK, and we are total staff of about 650. And finally, what lies ahead for BGS and for the world? Well, right now, it actually starts with where we are right now. That's a dinosaur here to the left. We're still in sort of COVID recovery. We're still struggling to find new ways of working and delivering what we want to do. But we're hopeful that it's going to become easier and easier as we go towards the end of this year. On the horizon, of course, very short term is COP26. But if you extend the thinking around that a little bit further, and we look to the energy white paper that came out of the government earlier this year, a lot of what will be driving the work that we do really has to do with powering up, getting ready for net zero, and being able to deliver on net zero. And we will be concentrating on that, as well as the environmental and hazard issues that we have in our remit as well. And with that, I am actually finished. Thank you.
Karen, thank you very much. BGS is clearly an incredibly important part of our cartographic heritage, but more so our geospatial future. So thank you for that fascinating introduction.